with straps to prevent muscle and bone loss in microgravity, because we don't feel it, but gravitational force opposes to our standing posture, and in this way stimulates our bones and our muscles to grow and to stay healthy and fit. Instead, in space, they don't have it in microgravity on the International Space Station. So they have to strap them to the treadmill and try to run that way. We will see that in a movie in a little time. And then they have meals and hygiene, obviously. They eat pre-packed space food. They rehydrate meals and use no-rinse shampoo and suction toilets adapted for zero gravity. We'll see it too. Then they have a very little free time, about 1 hour or less each day, in which they relax by watching Earth from windows, reading, listening to music, or video calling family on Earth. Sometimes they do like movie evenings, and they meet all together in one module and put on a very nice movie and see it all together. And then also they have to sleep, obviously. They strap themselves into sleeping bags attached to walls to avoid floating around, since there's no up or down in space. And they sometimes have to strap also the head, because they told us that the feeling that you don't have like a cushion behind you or on your side makes you feel like you cannot sleep. So sometimes they strap their head to a sort of pillow of cushion and they sleep that way. And also they experiments or have hobbies. Some do extra science experiments, take photos of Earth, or even glow plants as personal projects. It's not rare that we from European Space Agency or Italian Space Agency kindly ask to astronauts if they can make some extra science experiments, because we have so many things we would like to do, that we ask, and they're usually very, very kind and use their personal space to do more scientific research. So I will give you just a little example of what they do, from shampoo to treadmill to some other things. Let's see if it works. It should.
And rub it in.
She is
Again,
shampooing.
Working it out to the ends. And I like to take my towel while I have the shampoo in there and just kind of work it. Because without standing under running water, you kind of need to use the towel a little bit to help get some of the dirt out.
And that's it. Thank you.
It's a great sleeping bag. What's really cool about it, we can zip it up. Then we have little armholes.
What's on the menu tonight?
Strawberry shortcake.
Oh.
We have these butter cookies and some strawberries with a little bit of milk on top.
And Chris, I'm gonna make one for you right here. And here's your strawberry shortcake ready for you, Chris.
Oh, excellent.
Thanks for the help, Chris. That was awesome.
More. Okay, I'm gonna toss this. Works. Usually, with the honey coming out well there, you know, it's like just the right amount. Might have to use that as well. We've had to use that one time, which is a little bit scary inside of a spaceship using a volcano hammer, but it's done a good.
Here comes Luca. Now let's drive backwards.
I see it.
You see all the dust, they are not so worried because they have a very, very good filtration system for hair cleaning
Yes.
on the International Space Station. So anything that goes around will be
I
filtered
would suggest
and
dial
taken
the
off. I will now stop because we don't have so much time, but you can easily understand it, how it goes on. I would like to just show you the treadmill. If they... Here it is. Look. They're chained and strapped to the ground so that they can do like... And also this is a problem. You see everything moves around him because otherwise his movement will be transferred to the International Space Station architecture and it would move in the orbit. Instead, it does not to. So, and see, he comes up from one direction and the colleague is running on the other direction because there's no up and down. So it's quite funny, I think. Okay, so let's go to another question. Sorry. Okay, question 12. Who wants to read it? The other maybe?
What should we do with the space junk?
Thank you very much. So those questions are about space exploration. Space junk is a huge issue at the moment. First of all, we can track and monitor it. Scientists use radar and telescopes to track large pieces of space junk, predicting collisions to protect satellites and spacecraft. But it's not always so effective because, as I already said, we track large pieces. But what about the smaller pieces? Then we should remove big debris, at least big debris. Special missions like robotic arms or nets are being tested to capture and drag all satellites or rocket parts back to burn up in Earth's atmosphere. That's because it happens sometimes that satellites get lost. They, for example, have a problem in their functioning or expire their life before the time they were supposed to. And so they simply start to fluctuate around their orbit. And we cannot know exactly anymore where they are. So we try to find them with radars, and we are experimenting techniques to remove them and make them, be dragged into a lower orbit so that spiraling, they start to get closer to Earth until they enter atmosphere, and because of the drag, they start heating up, and at the end, they will simply burst into atmosphere, or at least burn into atmosphere. And now the main missions, the main ideas are robotic arms or nets. But there are many possibilities, and one of the big challenges of next years, and that maybe you could help us to solve, is exactly this: how can we remove space junk from bigger bodies that should be easier to find to very small ones that are quite a big number now? Another good thing would be design cleaner rockets. Engineers now build satellites and rockets that can deorbit themselves safely or move to a graveyard orbit when they're no longer useful. A graveyard orbit is an orbit that is upper if compared with the usual orbit we use for satellites, and it's not very useful, but is stable. And so some satellites get put in that orbit before they extinguish their propellant, and so they will stay there like forever and not interfere with other missions. But good practice would be recycle or reuse, which is already done in part. Future ideas include repairing or recycling all the satellite in space instead of leaving them as junk. One of the ideas is for every big satellite to throw up another satellite that could repair the first one, or could be added to that one and guide it with its own new propellant and extend the validity and duration of the mission. Obviously, it would be better to prevent more junk, so not produce it at all. Countries follow rules to limit new debris, like avoiding explosions in space, because as you can imagine, if you make something explode in space, every fragment would become a debris, which would be quite problematic. And design emissions to leave no trash behind, which is always good, but we still have to deal with what we have done till now. And ESA recently delivered this small film where it shows, these are debris larger than 1 meter in diameter. So every spot you see in the very small ones are larger than 1 meter in diameter. And the orbits you see, the larger one is 35,000 kilometers, and it's one of the most used. But you can see the inner debris, they are at the level of the satellites we use for GPS, communication, navigation, Earth observation. So they are very crowded orbits. And then it will show, if I don't make a mistake, that's it, objects that are between 10 centimeters on, from 10 centimeters on. So you can see together the ones that we saw before that are larger than 1 meter, and then all the other ones that are larger than 10 centimeters. You can see how many they are. Obviously, space is huge, and so they hardly collide, but they sometimes do and harm satellites too. And this is getting quite a huge problem. Usually satellites made collision avoidance maneuvers to avoid them when they detect them in time. And look at that. Those are the tiniest one, the one from 1 centimeter to 10 centimeters that are added on top of all the others. See, it's like a sort of cloud of space junk. It's really, really incredible. We in just less than 60 years of space operations have been able to put up in space so much waste, and we are still putting. So there are, as I read you, some techniques to avoid its increase, but it's a huge problem now. And those are those are the images with the ones from 1 millimeter up. So see how many they are. They sort of form like bubbles around for how many they are, streams. You see, it's quite important to find a solution to that. And we really, really hope that you young people will come up with some of your smart, good, and easy to manage ideas and help us to please those skies. So 13 questions. Who reads it? From Poland. This is a very important question.
Do humans have the right to exploit other celestial bodies?
Thank you very much for the questions. I will point it out in how many are? Like 5 points again. So first, ownership and rights. Currently, at the moment, and it has always been this way until now, no one owns celestial bodies like the moon or Mars or sun. As international treaties, like the Outer Space Treaty of 1967, you were not born, me either, but it has been like a huge step for humanity, this treaty, because it states that space belongs to all humanity, not individual countries or companies. No one could say this section or this territory on Mars is mine, or this star is mine, or I have exclusive access to a satellite. No one ever will, and no one ever has done that. And responsible exploration. Humans may explore and use space resources like water or minerals, but it should be done responsibly without harming other worlds or future scientific discoveries. As we told before, we have to be very careful not to bring on other celestial bodies Earth substances, living beings, and be respectful of their environment we are going to visit, and exploit it accordingly to their possibilities, not like we are doing on Earth, that we are ruining because we want from Earth more than what Earth can recreate. And so we have unbalanced our ecosystem. Responsible exploration also means not to harm the environment we are exploring. And this is a huge problem because there are some very, very pricey minerals on the moon and on Mars. And if we find a way to not only to dig them, but to transport them from those celestial bodies to Earth in an economical, convenient way, we will face a huge problem of companies that we want to exploit those celestial bodies and government that will have to stop them. And it will be very interesting to do to know how they will manage it. But it's a long way to get there now because we have huge problems with space transportation, as it is anyway quite pricey, luckily. Then we have ethical concerns. Just like we protect Earth's environments, we should think about whether mining or building on other planets could damage them before taking action. And that's what we already said. Just imagine, for example, Europa is a moon that has oceans of water inside. If you, I don't know, build something on it, put bacteria on the soil, the bacteria spread through water, you could alterate totally the atmosphere, the environment, because of the proliferation of those bacteria that have actually no antagonists there, and so they will spread freely and completely. And future survival. If Earth faces problems like overpopulation or lack of resources, using materials from asteroids or Mars might help humanity survive, but only if done fairly, because if we arrive not to have enough resources on Earth, it's not because Earth is poor, it's because we didn't manage properly our resources. And so if humanity has this problem on Earth, probably it will cause the same problem on another celestial body. So we first have to learn how to manage that on Earth and then eventually go abroad, very much abroad. Global cooperation. Experts believe space exploitation should follow international rules, ensuring no single group takes too much and that benefits are shared for all people, not just a few. This is another big problem because obviously richest countries are more prone to do space exploration and to exploit all the resources that come from that exploration as a consequence of mining or discoveries and so on. So in an optic of human race, we should be ready to share those richness that we find also with poorer countries, which usually are not just poor, they're just exploited on Earth too, unfortunately. So sorry. Okay. Oh, space travels. Who will read 14 questions? 14th questions?
Is it possible for a child to travel to the space?
Thank you very much. This is a question I think everyone has asked oneself at least once in a lifetime. So, current space travel rules are that most astronauts must be adult because space agencies like NASA and ESA require extensive training, physical fitness, and education, things kids haven't completed yet. But I can tell you that more and more very young people, I would say children, are studying so much and are so smart and become so, how do you say, so expert, really expert about subjects that the level of training they can reach at a young age has increased enormously lately. So who knows? Maybe one day a very young guy will come up and be so ready and so well trained and has done a lot of sports, has this healthy body and functioning mind and knowledge that nobody will be able to tell her or him, no, you cannot go, because he will be already ready for training. Obviously, there are health risks. The child's body is still growing, and the effects of microgravity, weightlessness especially, on bones, muscles, and the brain aren't fully studied, making space travel potentially riskier for kids. As, for example, we on Earth see when kids go underwater at a big depth. It's not very safe, and sometimes it's also legally impossible to make dives if you are very young. or to go very up in the mountains because air contains less oxygen and this could harm the brain. So we have some limitations because we are very careful about you kids, but you can always do the training, and as soon as your body finishes to grow, you can be extremely ready and so go on space very young anyway. Also, there are ethical and ethical questions. Laws and parents would need to agree, and scientists will have to be sure the trip wouldn't harm their child's development or education. This is a huge question because an experience such as going into space would be, like a life experience, and to have it very young could be a little risky because when we are very young, we don't have much experience of life. And so it's not obvious that we could deal with such a profound and impactful experience with the right character, with the right attitude. And in this, families would be very helpful. But it's anyway a question we have not to just to obliterate. Future missions. If we build space hotels or moon bases, families, including kids, could visit, but only after proving it's safe as Earth. That's because we are planning to colonize other planets, or at least the moon. But to have a little city or little settlement that is safe means we have to do a lot of research and to experiment a lot on human body living in space for long periods of time. Because yes, our purpose is also to have family living there, not just adults. So, 15th question, who's gonna ask?
Will space travel be possible when we grow up?
Thank you very much. So, I try to make like a sort of forecast of that. I imagine 20 years from now, around 2044, space travel will likely be more common, but mostly for astronauts, scientists, and wealthy tourists. Companies like SpaceX and Blue Origin may offer short orbital trips, while NASA plans moon missions, for example, the Artemis programs. So 20 years, you will still be very, very young, as you are so young now. 30 years, around 2054. Traveling to space could become safer and cheaper, with possible moon bases or even early Mars missions. Advances in rockets, like Starship, may allow more people to go, but it still won't be like flying on an airplane. So humanity, I think, will do some steps, but it won't be like, taking the car. When you grow up, next 10 to 50 years, you will be adult and you will be able to exploit some new technologies. If you train as an astronaut, engineer, or space tourist, you will likely have opportunities. Future tech, like nuclear propulsion or space elevators, could make trips faster and more affordable. The first Mars colonists, may be kids today, maybe even you, because it's very, very probable that your generation will be the first generation to land on Mars. Challenges remain, obviously. Space is dangerous with radiation, zero gravity, health risks, and high cost. Must be solved before even everyone can go. Governments and companies are working on these problems now. And looking at the pace we have had until now, there are good chances you will get to Mars. And hopefully for us, we will be able to plod you from Earth. Okay, so the last question, which was like four parts questions. So, does anybody want to read all the four ones?
Is it hard being an astrophysicist?
And also the other three ones, if you wish. Okay, I will read them myself. They are: what are some strange things you have seen? And how did you decide to become a scientist and why? And would it be possible for humans to live on Mars in the future? So the first one, it's easy. Is it hard to be an astrophysicist? No, it's so much fun because New discoveries are made any minute. I feel like I'm in a toy shop and I can buy anything I want. Amazing time this is to be an astrophysicist. You can see on the right, I just put you a very little extract, just 4 images from the, the, the best telescope as humanity we have. It is called James Webb Telescope and observes in the infrared band. You can see how amazing those are, like galaxies, stars in the center of nebula on the right. They are so amazing. And then, what are some strange things you have seen? I have witnessed some natural phenomena that I really wish you will witness too here on Earth. Nothing exotic, we would say, but they were so charming. I was able to see a total solar eclipse where I was able to see the corona around the sun, as you can see. Then I was able to see a total lunar eclipse with the moon so brightly red. And then, right last week, I was able to witness Northern Lights for the first time in my life. In 3 nights, I went to Iceland for holiday, and we saw them 3 nights, one after the other. It was so amazing, guys, because they are not only magnificent, but I think most beautiful part is that they dance, they move, and you can see those streams of particles developing in more branches, coming down straight and doing all these vertical strips that give you the impression of how space is deep. Because we usually look at the sky, but we don't really realize how big, how huge the space above us it is, where our eyes can go. Instead, with the auroras, with northern lights, you really get that feeling, and it is amazing. And then, last but not least, a thunderstorm on the sea. I was once near Rome, and I was wandering with my car near the shore. It started raining very heavily, very suddenly, and on the sea, I could see those hundreds of thunders going down all together with big noises and big lightnings coming up, and it was really amazing. And also, if you are in the car, you are in what is called a Faraday cage, so you have not to be worried to get hit by a lightning, as when you are in a plane, in an airplane. Usually, airplanes get hit by lightnings, but no one knows it because they are like isolated from Earth. So the lightning hits them and leaves them. So, how did you decide to become a scientist and why? I've always been very curious and grew up with lots of interest in the most random fields: figurative art, science, literature, sport, nature. So I was not extremely driven toward astronomy at first. It was only after I saw the first spectacular space images in the 90s, which for you now are like something ordinary because now we have James Webb Space Telescope and huge amount of space images. But when I was very young, there were not so many. We could get like, I don't know, 3, 4, 10 beautiful images each year. So it was really a big event. And at the time I was about to choose my university path, and I realized that astrophysics was what I wanted to study, because I could always imagine, explore, and learn without ever stopping, and know better and better what is around us, being astonished by it everything single time. Uh, Research is something that never ends, and it can be maybe a little scary at first, but gives you such a big sensation of freedom, because you know that wherever your mind is running, you won't find a border. The only border you find is the question you or someone else after you will answer to. So it's for me, very freeing. Then, would it be possible for humans to live on Mars in the future? I partially already replied to this. I think human race has huge resources and possibilities and could for sure live on Mars in the future, given time to make researches and make it safe for all of us. But I think that science and technology, without the ability to live peacefully with respect and love for other human beings, animals, and environment, are empty means and are even dangerous for other worlds and other civilizations. So let us make peace first, and then think about living abroad. So this was my last. And now, if you want, even if you have a very little time, I would like to switch to the other presentation that we have, which is the one about the planets. And I know you already have it because I sent it to you. So if you prefer to ask me specific questions about some of those slides, I would be really happy to answer. Otherwise, I would skip the longest parts, like anyone is speaking?
Dear Maria Elena,
Yes.
first of all, thank you so much for the exhaustive and fascinating work you did for our questions. You tried and answered all the questions. So thank you so much for your commitment, for your kindness to prepare everything. And now I think we can continue with the presentation. I don't think there are other questions to answer. And so you can continue. We watched the presentation in our classrooms, but I think it is beautiful to hear from your own words about this presentation.
Okay, thank you. So obviously, as it's almost noon, I will skip the part that you, I think, already saw, which is those charming videos, and also the location of our galaxy inside the local group, and how we can arrive to our Milky Way, where it is, and so how is this interstellar medium. Those are beautiful images of Ultra Hubble Deep Field of 2014. Each of those spots you see is a galaxy. It's so amazing. And galaxies are the result of a big evolution from what we call Big Bang, and through times. And so they keep the spinning. You see, they are always turning. They keep the spinning that came from that very, very early age. And so this is very nice. This is relative cosmic velocities. So how fast things happen. And so you can think that we are on Earth and Earth is rotating, but we are orbiting around the sun. Sorry, we are orbiting around the sun. I don't know why it doesn't, it should, like, okay. And the sun is orbiting around in the Milky Way, and the Milky Way is orbiting relatively to the cosmic microwave background. So we are going at least at 2,160,000 kilometers per hour, at which we have to put on top all those other velocities. So we think we are like stable and still, and the movement we have is just the movement we provoke, but it's totally not like that. So this is a little imaginary of the solar system with things on scale. As you can see, Earth is a little small, especially if compared to the sun. Look at how tiny Mercury is. And here we have some moons too. So this is a little GIF about a good reproduction of rotation timing of planets around the sun. These are some indications of how the planets are tilted. You see Uranus, sorry. Uranus is the only one that is rotating totally in a weird way if compared to any other. And see Venus, how slow it is? One day in Venus is 245 terrestrial days. So it's very, very slow. And this is gravitation on the planets. See how one it is on Earth. We are quite fast, but not that fast. Jupiter is body on Jupiter would be faster, but for example, body on Mars would be slower, as gravity on Mars is lower than on Earth. So this is a little introduction to what an electromagnetic spectrum is, but at this time I think you already know it, because first we saw it last year, and then I suppose your teachers told you anything about that. And so just a quick look at that. We have different kind of electromagnetic radiation going from gamma to radio. that changes in wavelength and frequency. As you can see, the shape of the wave is different. Are visible is just a very, very tiny bit. But luckily, we can build telescopes like, for example, Hubble Space and James Webb. Hubble Space looks into ultraviolet and first infrared, and James Webb in large infrared bands that can see better than our eyes. And so I put you some examples. This is an Hubble image and this is a Webb image. This is an Hubble image and this is a Webb image. So you can put in comparison things that have different features depending on what part of the radiation they sent you, you collect. Oh, so let's start very quickly with our planets. I will try to be very quick. So this is Mercury. I put a divinity statue for each of them. This is a little explanation of the orbit. It's the closest planet to the sun. Its diameter is 4,800, about 4,000, about 500 kilometers, which means it's roughly half of Earth, about. Surface temperature has very big excursions, obviously, because it's very close to the sun. So on the opposite to the sun, the temperature is minus 175 Celsius. But on the side facing the sun, it is 427 Celsius degrees. So very, very hot. It has no moon. It is relatively old, 4.5 billion years, and it's rocky, essentially. It has a solid inner core, an outer molten core that has not yet solidified, and the mantle. We can only see the very tiny layer on top, which is the crust. Fun fact that I wanted to report you. A year on Mercury is just 88 Earth days, but a day lasts 59 Earth days. So it's weird, you know, because the year is shorter, but the day is very long. It means that the velocity with which Mercury revolves around the sun is quicker than the Earth, but the velocity with which it turns around himself is so much lower. It is covered in craters like the moon, and if you can see, it resembles a little the moon. And it's shrinking because its core is cooling. And as you know, if you have any material apart rare ones like yes, anybody talking? Oh no, okay. When you heat something up, usually it expands, and when you cool it something down, it shrinks. So as Mercury is still cooling, it's still shrinking. Venus, look at how gorgeous she is in the Louvre. So Venus, yeah, well, Venus, we could say it's quite aggressive, actually. This is how you can see it from outside, cloudy, essentially cloudy. You can see it in ultraviolet or radar and see there are a lot of things going on the surface. The diameter is quite good, about 12,000 kilometers, similar to Earth. Surface temperature is 4,065 Celsius, so the hottest planet in the solar system. It has no moon, same age as Mercury, more or less. The composition, rocky surface with a thick atmosphere of carbon dioxide and sulfuric acid clouds. This means that if you put anything we have on Earth on Venus, the acid will corrode it and it will not exist anymore. That's why we never tried to put probes toward Venus, to send probes toward Venus. We just have them going around its surface and taking these spectacular images. Venus spins backwards, we saw it before. Its sun rises in the west and sets in the east. It's called Earth's sister planet because they're similar inside, but only in size. Its thick atmosphere traps it, making it a scorching greenhouse of sulfuric acid clouds. So it's really terrible. Earth, our planets, our home, sweet and beautiful. Third planet from the sun, diameter same size as Venus, more or less. Surface temperature minor 89 Celsius to 57 Celsius. One moon age, same as the other. Composition, rocky surface with 70% of water, hydrogen, oxygen, atmosphere. And I would like to make you note that the percentage of water we have on the earth is about the same percentage of water we have in our body. Isn't it cool that we have rocky surface on earth that is 30% and we have not watery structures in our body that are about 30%, like bones, for example. Fun facts, Earth is the only planet known to support life. 70% of Earth's surface is covered in water. Sorry, I replied this again. Earth's atmosphere protects us from harmful solar radiation. Sorry, I'm trying to be quick and and I sometimes make mistakes. I wanted just to give you a little example here, just a quick example of what it means to observe Earth from satellites in a different wavelengths. So from ultraviolet observation, we get images like this, where we can detect the ozone holes and atmosphere characteristics that are useful to detect gases, holes, problems. Visible light, well, land surface, obviously. It's Earth as we see it from our eyes. It means they are like detailed photographs of what we have on our beautiful planet. Then in infrared, we can detect a lot of things. For example, land cover, which areas are desertic and which areas are even slightly covered with vegetation. Chlorophyll concentration, which means if you have different areas with different plants, which ones produce more chlorophyll, so more oxygen, and which not. And then land surface temperature and sea surface temperature, that unfortunately, as you know, they're rising. Water vapor, so concentration of humidity and dampen. Soil moisture, so how much water is inside the soil. And then in a microwave, rainfall structures, because microwaves can see through water and so they can detect also the amount. As you can see, our structure is made by an inner core that oscillates, and that's why Earth axis wobbles a little, as we said at the beginning. There's a little outer core, liquid outer core, then our mantle, and then our crust, where we all live. And you can see it here, how subtle it is, and how what is in the what we call plum tail, okay, comes up into volcanoes eruptions. And Mars, our strong, challenging, closer planet. We have so many things going on Mars. We have robotic inhabitants. We even have an helicopter that has flown for a lot longer than what we expected. We have rovers taking selfies of themselves and of the helicopter. And we have also two moons, Deimos and Phobos. This is Mars for what it is for what it is in real colors. This is the animation made by NASA. And what you can see here are called dust devils. They are small tornadoes going on the surface every time of the year. And sometimes they get so strong they become like storms and cover completely areas with this more or less reddish dark powder. And so the landscape of Mars is different almost at any time of the year because of these storms. And if you have, the last thing I will tell you is if you look close very carefully, you will see a very big mountain somewhere here, which is, maybe I have to put it back, which is the highest volcano we have in the solar system, which is called Mount Olympus. Thanks to, this is here. Can you see it? Wait, just a second. Here it is. This is the highest of the whole solar system. And it has two moons, Phobos and Deimos, as I told you. And the excursion is quite big. It's from minus 125 Celsius to 20 degrees. So it's fairly cold. Well, some of them I've already told, so I can go on. Oh, here is Jupiter. Do we have time? Is anybody going right in this moment? Do I still have like about 10 minutes, 5 minutes? Just tell me, please, Monica, so I can arrange myself.
Okay, dear. Yeah, 5 minutes. Okay.
5 minutes? Okay, so I will go with Jupiter, maybe another planet, and then
Yes,
we will close
and
it.
finally, before leaving
Yeah.
our partners, we can show you the classrooms if you like.
Yeah, please. If you want, I can just do Jupiter and then you show me because I would be really happy to say
Okay.
hello to you.
Okay, thank you.
Okay. Okay. So Jupiter is the fifth planet from the Sun. Its diameter is huge, 140 kilometers roughly. It's the largest planet on the solar system. It's like a huge fluffy ball of gas. Its surface temperature is minus 108 with very low excursions. It has 95 moons and is mostly made of hydrogen, helium, and possibly there's a little rocky core. What you are seeing here is infrared, visible, and ultraviolet. In different wavelengths, you have totally different images showing the inner structure of all those currents of gases you see here. Jupiter's great red spot is a giant storm that's been raging for over 300 years. It's so big that more than 1,000 Earths could fit inside of it. It has faint rings. Oh, sorry. It has faint rings, but they are hard to see. Just I will be very, very quick and do something also about Saturn because I really like Saturn. It's the sixth planet from the Sun. Its diameter is around 120 kilometers, quite cold, and it has 274 moons. And the last like 100 have been discovered like very recently, a few months ago, because they are so little and so and moving so far orbits that at first people didn't think they were Saturn's moon. Instead, they are. So he has a huge record, 274 moons. We only have one. You can see some of them here. They're the biggest ones. You see, Pan is one of the biggest ones, but it's so tiny even in comparison with the others. You know, on one of them, we sent a probe, and it was Titan, and we saw what is under the surface. It has a methane. Um, how do you say, atmospheric system with lakes, rain, clouds, streams, but it is made of liquid methane, so not based on water. It has auroras, like also Jupiter has. Sorry, I didn't think I put you a photo about that, but it has them. They are amazing. Oh, yeah, so I put it here. Also, Jupiter has auroras. And another weird thing is that it has an hexagon on the top of the pole, and it is made by storms. And no one has really understood until now how it is possible to keep such a perfect hexagon for the whole year. And those are some big expanded images of the rings that are very, very subtle and made mainly of ice with some little rocks. Okay, I think you will be able to look at the others yourself so that I can give you a little hello if you are happy with that. I will interrupt the sharing. Okay.
Thank you so much, Maria Elena. Nice presentation and huge work of you. Thank you so much to you, to ASI, the Italian Space Agency, for allowing this meeting. Thank you so much. And now, dear partners, dear Nursen, now stop recording, please. Stop recording. And dear partners, we can show our classrooms, our students.